In the previous video, we had seen what is n of C1, n of C2 and n of C3. Now, let us see what is n of C1, C2. Let us first understand what is C1, C2. Consider this table. I had told you that earlier C1 was locked, which means we had considered those permutations where C1 or C2 or C3 alone was fixed. But now this is a condition where C1 and C2 are both locked, which means C1 and C2, these both couples are, couple 1 and couple 2 are both sitting beside each other. Now out of 6 people, 4 are gone. How many remain? 2 people. Let me name them as P1, P2. So we have people as P1, P2 here and the 2 couples C1, C2. In how many ways can these arrangements happen here? Permutations of these 4 people. Please remember, I am considering C1 as one object, C2 as another object. Do not get confused with C1, C2 and couple 1 and couple 2. What do I mean by C1 and C2 when I write the diagram is couple 1 and couple 2. So, couple 1 is considered as one object, couple 2 is considered as another object, and I have P1, P2. How many permutations are possible? C1, C2, P1, P2 is one possible permutation. P1, C1, C2, P2 is one possible permutation. Another one is P1, C1 and P2, C2. This is another possible permutation. So on and so forth, we can go on listing. But how many of them are there? Let us see. For 4 distinct objects, as we had seen earlier from the formula, they can be arranged in 3 factorial ways. How? 4 minus 1 factorial, which is 3 factorial ways. Earlier, in the previous video, I had proved this to you by showing bijection. I am not going to repeat the same, but you can do it all by yourself. In the earlier video, what we had done is we had appended C1 in the bijection proof. But you need not take C1 always. For that matter, out of 5 objects which we had considered there, you can take any one and append any one. Right? And you will be obtaining the same answer. So according to that, 4 distinct objects can be arranged in 3 factorial ways. And hence, n of C1, C2 happens to be 2 square into 3 factorial. How is it 2 square? Earlier it was 2 ways. Husband, wife, wife, husband for one couple. Now, this is true for couple 1. They can sit either HW or WH this way. But it is true for couple 2 as well. And by rule of product, we have it as 2 square into 3 factorial. Right? You can probably enumerate the different possibilities and check it yourself. HWWH, the 2 couples can sit like this, or HWHW, they can sit like this. WHWH, this is one possibility, and WHHW, this is another possibility. So in these 4 ways is how we get it as 2 square, right? So now for n of C1, C2, it was 2 square into 3 factorial. Same holds true for n of C2, C3 and n of C1, C3. It is 2 square into 3 factorial. In these many ways, they can sit. Now, the next question would be n of C1, C2, C3. In how many ways can these 3 happen like this? Consider this table. C1 is locked, C2 is locked, C3 is locked. So, we have 3 distinct objects here. Couple 1 is one object, couple 2 is another object, and couple 3 is yet another object. So, what are the different permutations possible? The different permutations possible can go something like this: C1, C2, C3, C1, C3, C2, and so on. Now, from the formula, we see that it is 2 factorial. Why? 3 distinct objects can be arranged around a circular table in 3 minus 1 factorial, which is 2 factorial ways. Right? But we have 3 couples here, and one couple can sit in 2 ways, right? HWWH. So for 3 couples, it will be into 2 cube. Did you get that? So n of C1, C2, C3 happens to be 2 factorial into 2 cube. And now we are done with whatever we wanted to find out the answer. What is the final answer? So n of C1 bar, C2 bar, C3 bar happens to be S0 minus S1 plus S2 minus S3. This was the formula which we have learnt. So, what is S0? S0 is all possible permutations of 6 people. Why 6 people? Initially, we started with 3 couples, which means 6 people. All possible permutations is how many? 6 people sitting around a round table. In how many ways can they do that? 6 objects can be arranged around a round table in 5 factorial ways, and hence it is not 6 factorial, it is 5 factorial. Please do not get confused. It is just a matter of your pen and paper writing, and you will understand things very clearly. Now, what is S1? S1 is n of C1 plus n of C2 plus n of C3. So minus S1 happens to be minus 3 into 2 factorial, right? 3 times it is the same thing, 2 into 4 factorial. S2 is n of C1 C2 plus n of C1 C3 plus n of C2 C3, which is 3 into 2 square times 3 factorial minus S3 is 2 cube into 2 factorial. Now, this big expression will give you the formula, or it is the answer for your question that in how many ways can these 3 couples be seated at a round table such that no husband and wife will sit beside each other. So if you want, for your better understanding or for completeness sake, you can solve it yourself and find out the answer.